When you go to a fruit market to buy apples, okay, if a shopkeeper is there, how apples he is keeping, based on that you will get the good apple or bad apple. Right? Getting a apple good is a one, otherwise it's a bad. Is that is okay? Let's say now let's imagine he is keeping most of the times 80%, 70% of the times good apple every day. But every day, let's assume it need not be this case, but let's assume every day he is keeping only 20 apples. How many apples? 20 apples. So in that, only 70% of the, on an average, 70% of the apples are good apples. What is the meaning of the on an average? Sometimes maybe 60, sometimes maybe 80, but when I take in the average, it is coming. Okay. So these are the 20 days, right? You close your eyes, what I'm doing. Don't even look at it. Okay, let us look at this. So I collected the data of 1 year. What is this? Up to 21. You go and look at. This is a day 1. This is the day 1. How many apples you kept? How many are good apples? Sai Venkatesh, mute your mic. I'm muting it. Okay. So what I'm saying is, this is the day 1. How many apples you kept? This is 20 apples. If you look at 21, I started from second and ended. So there are 20 apples. In the 20 apples, how many are good apples? 1, 2, 3, like this. So if I sum these and kept it in the sum of apples, total apples, good apples, total good apples in a day 1, day 2, day 3, like that. So this is, each one is a Bernoulli. This is also another Bernoulli. So like this, if I add all these Bernoullis, what is the total is going to be? The total is going to be a binomial. All are with me now? Is the point is clear how the binomial is going to look like? This is another random variable. Binomial also another random variable. Let us see. Let us calculate the total of this. What is this? Column statistics? No, row statistics. I need to sum of these results in here. How many apples? First day 1 he kept the good apples out of 20, 18. But actually the mistake, most of the people in calculation, what they do the mistake is 20 apples. 70% from the past I know. So 70 into 20. 14 apples are the good apples. I should get it. But NP, as per the last class, NP is what? Average? Yes or no? This N20 into 0.7 is the average number of apples, good apples. You guys are understanding? But normally, whenever you ask, they report this NP. But some day it is 18, some other day it is a 14, some other day it is a 13. You guys are clear? So this I'm calling as a X that follows a what distribution? Binomial distribution. Is the point is clear now? So let us go and look at how these apples, how many days he sold only good apples, I am saying. 18 apples, 13 apples, 12 apples, like that. Is that is clear? How to do that? Tables. I went to tables. I'm taking this. I'm looking at, yeah, percentage and count. Now look at here. Let us understand this. What is the meaning of this? In There are total 1 year data, right? How many days? 365 days. Yeah, let's look at it. 5 days, he kept only 9 good apples. Out of 365, there are 5 days, he kept how many apples? Only 9 good apples. All are with me this. So what is the meaning of that? If I go and look at here, how many 9s you are going to see here in this column? Huh? Only 5. Only, is it there? It's not there. I don't know. We need to, sorry, 9, right? I need to look at 9. 9 apples sold for how many days? 5 days. Yeah, let's look at 9 here somewhere. Yeah, here 1 day. But still he kept how many apples? Total 20. Out of that, how many good apples he got? 9 apples. All are with me what I'm saying. Guys, all are with me what I'm saying. Pull the chair, pull the chair. So these are total. He is keeping every day 20 apples. Out of the 20 apples, on that particular day, how many good apples? Only 9. Right? So how this 9 came? Based on the past data. If you go and look at, let's look at here. I'm keeping one more column. Let us keep it one more here. Calculate the percentage. Calculate the percentage. Percentage. Every day, what is the percentage of the apples he kept? Let us see. That total divided by 20. Calculate that. Percentage of good apples. In which column I need to take? Column 2 or column 1? Column 1 divided by 20. So if you look at one day he kept 90% of the good apples. Another day he kept 70% of the good apples. Another day he kept 65% of the good apples. But let us look at overall. Overall in the sense what? Sum of all the apples good in the 365 divided by 20 into 365. You guys understood this calculation? Guys online, please respond. What I said? I am calculating what happened in the past. Now these apples arranged in a day wise. Instead of that, if I put everything in one column, everything, let us keep it everything in one column. What is going to happen? I'm keeping this in one column and stack. Stack means what? Next, add this data into the next 21 observation onwards. All are with me? Okay. Now, instead of doing that, what I'm going to do, if I add all the sum of these, what I'm going to get it? The total number of good apples sold in 365 days. If this point is now, let us calculate that. I'm calculating the simple. I keep this also. Sum, I want sum only. Where is the sum? Sum is this, right? What is this? 5116. Total number of good apples. In how many apples? Huh? 20 into 365. You guys understood this? So let us calculate now. This divided by 20 into 365. Let's say I'm asking to store in some C25 result. You got 0.7? You guys understood this? So now this 0.7 choose the data better it is. This will become what? P or P naught or what it is? This is a P. Money. So tomorrow if you are going to sell, let's say 20 apples or 10 apples or whatever it is, based on that I can use the binomial distribution to calculate the probability. Now let's look at this. How the data is going to look like. I think you are not understanding anything, I believe. Yeah, it's a Greek and Latin. Let's look at this. What is the probability that a given day he is going to sell? How many days he sold 8 good apples out of 365? Only one day. You guys are understanding this? So what about this? How many days he sold this? 47. So how many times he appeared? It appeared 47. So this will become 1 divided by 365, 5 divided by 365. This will become the probability. Yes or no? You guys understood this? Okay. Now let us understand this. The confusion. Why you guys got the confusion? What is the meaning of the? Let me spend a little bit of more time. Exactly. At most and at least. Okay. What is the meaning of the first? Let's say this shopkeeper is a very good shopkeeper. Very good means what? All the time he keeps all the 100% good apples. Okay. What is the chance that he is going to keep exactly 5 good apples? 0 or not? Exactly. All the time he is going to keep only good apples. 0 or not? What about the exactly 7 apples? Still it is 0. What is exactly 10 apples, 10 good apples, 0. What is exactly keeping the good apples? You guys understood this? You guys understood this, friends? What about? You guys need to respond. You cannot sit just like that. I cannot see your faces. Okay. Now I'm asking, if I say, yeah, maximum you keep only 15 good apples, you get angry or not? Why? You are so accurate, right? But what is in terms of the probability? What should I say if that is the case? Getting a 15, I'm keeping all the good apples. Getting maximum of 15 good apples, maximum. I don't get beyond that. I go to the shopkeeper, but I get maximum of 15 good apples. What is the probability? 0. You guys understood this now? Friends, things are clear or not? Things are clear? Okay. Now, at least, if I say, always he is keeping all the good apples, right? If I say, can I pass this statement like this? Yeah, he keeps at least 2 good apples. Possible? At least means what? I'm having at least 10 rupees means what? 10 say some million, trillions and all, right? He's having at least 10 rupees. What does it mean? Minimum come say come, he is having a 10 rupees in his pocket. It can be 1 crore also, 1 lakh also, 1 million also, 1 trillion also. Now, what is the meaning of that list? I'm saying he keeps at least 2 good apples. Is this accepted statement given he is keeping all the good apples? Is it an accepted statement for you? So what is the probability of that? Is it maximum or minimum? Huh? Is it a probability? What is the probability? It is going to be, when I calculate the probability, it is going to be maximum or minimum? Maximum, nah? Because I know from the data, he's always keeping all the good apples. At least 2 to milta hai, right? Friends, if I say 3, still it is a valid statement. But what about he keeps at most 2 apples? Is it a valid statement? So you should assign what probability? 0. You guys understood, I hope. You guys, okay. 20 days. Actually, what is this? 0.7. 70% of the times he is keeping good apples. If let's look at the next apple. What is the chance that is going to keep the next apple? What is the chance that it is going to be a good apple or bad apple? What is the chance that it is going to be a good apple? Only 70%. You guys are understanding this language? Overall, he is keeping good apples only 70%. Next apple you are going to choose. What is the chance that that apple is going to good apple? 70%. You should visualize. That's all. So this is the batch number 1. How many people I trained? 20 people. How many people got the jobs? Let's say 1 getting a raise or not getting. Out of 20, how many got job? And out of another 20, second batch, how many people? Only 14 people, they got the job. So like that, how many batches I trained so far? 365. Now tomorrow, you came for the counseling and asked, sir, I joined your course, but tell me, what is the chance that I am going to get a job? How should I look at it? You are going to get a job, the chances are how much? But once you got a job, it's 100%, right? You got a job already. But at the time of, based on the past data, what I am going to say? 70%. Is the language is clear? So the next person comes for the counseling. Still I say, yeah, there is only 70% chance that, because that's what happened majority in the past. You guys are clear on this? So for each apple now, what is the chance that it is going to be a good apple? 70% only. You guys are enjoying the discussion or it is going top of your head again? Huh? Now, let's look at it. But this, if I want to plot the histogram, I mean the bar chart, how should I do for this X? I need to do like this. X. What is this? Total number of, what is this? Good apples. Now you tell me, what are the different values are possible for this total number of good apples? When I'm selling, when I'm keeping 20 apples, what are the chances for this X? 0 to 20 or 365? 0 to 20, because I may get 0 apple, 1 apple, 2 apple, 3 apple, 4 apple, like that. You guys are understanding? So this will become 0, 1, 2, 3, like 20. Now I need to calculate the probability of 0 good apples. I'm not going to get any good apples. Is there any in the data? If you go and look at, is there any time there are only 0 good apples? Any day? No. You guys are understanding? Exactly 0 good apples. What is the probability? 0. At most 0 good apples. 0. You don't get it now. Maximum. Some apples you are going, because the probability of getting a good apple is how much? 70%. So what I'm saying is, if someone asks what is the chance that you are going to get 0 good apples, already he is keeping the 70% of the good apples on an average. What is the meaning with this on an average business? Let us understand that first. I'll come back to that part afterwards. So I'll come back to that probability distribution curve afterwards. Let's understand what is the meaning of the average. Average is nothing but what? These are the X values. One day this much second day, this much third day, this much like this. These are what? Different values of random variables. What is the average in our mathematical notation? Agreed. What should I do? This plus this plus this plus this plus add all these things. 18 plus 14 up to let's go slow because I don't want you guys to feel divided by how much? 365 or 20 into 365? 365 only, because you are adding the numbers in the numerator only 365 times, right? Yes or no? Yes or no? How much I am going to get? Calculate the descriptive statistics of this. When I simplify that, how many? 14.016. But 14.016, it doesn't make sense. We say 14 apples. On an average, how many apples he is giving? 14, which is equivalent to NP. How much is the N every time? How much is this? P. How much is this? Matching? You guys understood this now? So the formula what we derive? You guys are clear or not? What is the meaning of the average? Friends online? Is this clear? The calculations? How that NP? Strictly speaking, I should write NP not, but we collected the sample data and did the business. So I need to keep only N. Agreed? Mandi. Online. Happy at least now. Now let's look at the variance. What is the variance? Variance of these, right? Yes or no? Already we calculated. Did I? It's not there. Let me calculate that. What is the variance? 4.25. What is the meaning of this? Deviating from the center means what? This side, if this is the center, this is a 14, average is the center. This side I may sell some apples, this side also I may sell some apples. So how much I may go this side? Around 14 minus 4, 10. Yes or no? And this side how much? 18. You guys understood this? You guys understood this? That's what is the meaning of this. But instead of collecting in real world, I give only this data, that's all. Only one. Next month or tomorrow, how many apples I am going to sell, right? You're not going to get all these data to calculate the variance. So how can I calculate the variance? Using this. We derived a formula for variance, right? What is that? I can use this. What is that? How many apples every time? 20. P is how much? 0.7. Q is how much? 1 minus 0.7. 20 into 0.7 into 0.3. Calculate and tell me. Calculate and tell me. 21. 21 into 2. 4 point something. Calculate and tell me. Why you guys are only you guys use the WhatsApp, Facebook only? Use your mobiles and tell me. How much? 4.2. This matter so or If I have the data, I can calculate like this. But in real world, you are not going to have this data, right? Yes or no? So I should not use this method to calculate. Only I need to use this method to calculate. You guys understood? Spurti, this is clear now? Here also, in real world, I am not going to have this kind of data. Only I am having this data. Because I know from the past, only 70% of the are good apples. Tomorrow, let's say I am going to sell 20 apples. What is the average number of good apples? What is the meaning of the average? What is the meaning of the average? One day I may sell 14 apples. Another day I may sell 0 good apples. Then the probability of being a good apple, right? Possible. If the 10% of the times only is going to keep the good apples, what does it mean? Someday you may get all the bad apples. Let us look at that example, if that is possible. What I'm saying is, close your eyes, don't see what I'm doing. Now look at this. So this is another data set. This is another data set. What is this data set? This is also, let's look at as a apples case. Now this is another shopkeeper. Let us understand how he is behaving. Is that is okay? Okay. Day 1, how many? These are day 1, day 2, day 3, day 4, like this. Each day, how many apples he is selling? 20 apples. Out of the 20, how many are good apples? I don't know. Let us go and see. So what I can do? If I add all these things, I'm going to get number of good apples per particular day. If I add all these things, 20 are there. So I denoted 1 as a good apple, 0 as a bad apple. So if I add all these things, what I'm going to get? Total number of good apples on the particular day. Good. Add. Row statistics, sum, right? I'm asking to store. Let us see tables. Tables are going to give, yeah, still is not, but how many good apples he is keeping as low as? 3. And what is the chance that he is going to keep the maximum 16 as good apples? Very, very less, right? 16 good apples out of 365 days, he kept how many times 16 good apples? 3 times only. Why it is happening like that? Let's go and calculate his total, how he is going to keep the good apples and its probability. All are with me? So how can I calculate the probability? Add the total of 0, 1, 0, 1, and the probability is nothing but the average, right? How much is that? So I can take the sum of all these things. Sum of all these things is going to give what? In the total 365 days, every day 20 good apples. Total number of good apples in 365 days. Is the point is clear? Calculate that total. So how many total number of good apples? 3660. These are total number of good apples in what? In a year? Every day how many good apples? Every day how many good apples? How many apples is selling? 20 apples. So total number of apples is how much? 365 into 20. You guys are able to follow? Okay, let's calculate that. Three, 6, 6, 0. Am I right? Yeah, I hope I did the right. How much is this? Only 0.5%, 50% on the chance. On an average, how many good apples I am going to get if I am selling every day 20 apples? 20 into 0.5, 10 apples only. So if I go and calculate the average of all these, how much I am going to get? How much I am going to get? 10 only, right? Let's do that. Is it matching? Without having the data, if you know the P, I use the entire data to calculate this average, right? But if you give the P value, that is how much in this case? 0.5. If you give that number, and if you tell me how many apples you are selling, I can calculate. No need me to have this entire data. You guys understood this? In the real world, you are not going to have this entire data. But you are going to have what? Only the P value. What happened in the past? What happened in the past means what? How many good apples he sold. That only you are going to have. For example, so that's the reason, collect as much data as you can. How much is the data I need to collect? Of course, I can show some calculations, but that calculations are not going to be helpful, I'm telling you. Collect as much as you can. Now, even your calculations is saying, let's say, some thousand data points, but it's highly impossible to get the 1,000 data points. Let's say number of earthquakes in a year. Your data is saying that you should do the analysis after collecting the, let's say, 100 earthquakes data. But 100 earthquakes, when they are going to come? You want to wait till then, and then only you do the analysis. You guys are understanding the problem. Sometimes, even you want, it is highly difficult to collect the data. Then my answer, my experienced answer is collect the data as much as you can. Clear? Is the point is clear, guys? Number one. Let's say I am having only this data. Before we calculate the 0.5, right? Assume that is a very accurate. Now I collected only the 10 days data. Each day is selling how many apples? 20 apples. Based on this, let's calculate. Definitely, this is going to be very much away from the 0.5. So your interpretation also going to say, let us do that instead of talking in air. How can I do this? I need to take the average of this. I can take the average of this. Yes or no? Let me go here, calculate average. How much is the average? It is coming 10. Luckily, it is matching with the previous this thing. Let us calculate the P. How much is the P? How much is the P? I need to add all those things. How many? 94 divided by, let me do this. Calc 94 divided by this, right? 20 into 3, 20 into how many? 10 only. So no guys, I collected only for 10 days, not 365 days. How much have we got? .7. There is some deflection, right? Actually, I should get how much? 0.5. Now I got how much? So if you guys are getting. So based on the sample, your things are going to change. What is the best solution I can have? Collect the data as much as you can. Make sense? So it's highly impossible to know your population anytime in the real world. Of course, if I'm tossing a coin, you know the population. What are the population there? Head or tail only. You are throwing a die. What are the things? 1, 2, 3, 4, 5, 6. You know the population there. You can't get more than that or less than that. So what I'm trying to say is, few instances it is possible to collect the population, but majority of the instances which you are going to work, you never have exposure to the population. Only you collect the sample. If the sample is the representative of your population, that's good enough. All clear? Okay, next question. In this example, good apples per day and some good apples for 365. The two binomial random variables, right? I am asking my random variable is total number of good apples sold in a day. Let me write it. X is what? Let me be specific. Total number of good apples in a day when I am selling, or when I am in the sense of the shopkeeper selling 20 apples. Is there any question now? Sarupa, this random variable I want to study. This random variable only I want to study. Per second, how many good apples? That is a different random variable. I'm not interested in that. I'm interested in this random variable. This variable. Make sense? Sarupa, this is clear now?
Yes, sir.
I want to study this. I don't want to study anything else.
But this random variable is input for the other one, right? The total number of good apples per 365 days.
No. She's saying total number of good apples 365 days is another random variable. Where?
Yeah.
Total number of good apples in a day. This. When you are selling. There she's saying total number of good apples in a year. That's going to be a different number. Because you need to choose the year, every day how many apples he is selling, and go and count how many good apples he sold. That will become the 6. Both are different. But that also binomial. But that is a different binomial. All are with me? All are with me?
And that binomial variable is dependent on this one, right?
Of course.
Okay. We need this x to calculate that one. Okay. Yeah.
Of course, you can use that.
Got it, sir.
You guys understood? What is your question is? If I am interested in 1 year, your x will change accordingly. Agreed or not? That n value is going to be different. In a year, how many total number of apples you are selling? Maybe 365 into 20 will become my n. Yes or no? So my x is going to take the values what? 0 to that big number. In this case, my x is going to take what values? In a day, I may sell 0 apples, 1 apple, 2 apples, 3 apples, 4 apples, 5 apples, up to 20 apples. So x can take only 0 to 20. But in case of the 1 year case, how many? 365 into 20 is the maximum number of apples, good apples possible. There may be 0 good apples also. So 0 to 365 into 20 good apples. Not good apples, apples. Total number of apples. This is a possibility. So when x value, what are the values it is going to take, the distribution also going to change. So that is a different binomial random variable. You guys are understanding? 70% of the times I sold the good apples. I mean each apple being is a good apple is a 70%. Now I have 20 apples. Tell me how many are going to be the good apples? Huh? How much? 20 into 0.7, 14 apples. This is average, right? Average means what? Center? Center means what? 50% chance? Yeah. Yes or no? What I'm saying is, where your manager and yourself is going to have a problem. Here 14 apples, right? What is this chance? This is a mean, na? Mean is nothing but what? Q2. Q2 is nothing but what? 50%? Center of the data. So this is going to happen with a 50% chance. You guys are understanding? You guys are understanding what I'm saying? When, if it is a symmetric distribution, if it is a skewed distribution, this percentage will change, right? Anyway, we'll come back to this afterwards. I'll take it up some other content which I already discussed, like E of X, V of X. Let us get a feel of it first. You guys are okay? Okay. Problem. Let's take some example 1. Yeah, HR analytics problem. HR analytics. Stop HR analytics. Okay. HR analytics. What is this HR analytics problem? You guys know, whenever there are some positions opened, okay, they send the resumes. Okay, start HR analytics. Let me talk about the simple problem. Manufacturing problem. Some manufacturing problem. I'll solve around 10 problems. Don't worry. What is this manufacturing problem? Let's say there is a lathe machine. How many of you guys know what is a lathe machine? The machine which they use to prepare nuts or bolts. Sorry? Yeah, there is a lathe machine. Produce the nuts and bolts. Let's say some nut or bolt, whatever it is. Okay? So this is what bolt, right? The bolt is going to look like this, or nut. It's a bolt. So let's say this length should be let's say 2 mm. How much it is? Not 2 mm. Let's say 1.5 centimeters. If this length is 1.5 centimeters exactly, then I consider that as a good bolt. Otherwise, bad bolt. All are with me? So let's say in the past they might have produced some number of bolts. From there I can calculate the p-value. Yes or no? So now let's take that example and understand. So from the past they produce the data like this. This is the data. That's how they done the job. Let's say some what is this? They first nut, first bolt. Is it as per the requirement? Yes. What about the second bolt? It is not as per the requirement. Like that, how many bolts they produced in the past? Around 10,000. All are with me? So can I calculate the P from this? How am I going to calculate the P? Sum divided by total number. Sum is how much? Let us see. Sum of the total number of bolts. Where is the sum? Around 59. Yeah, it's not 10,000. I think 1 lakh, I believe. It's a 1 lakh. Is a 1 lakh? Here it is a no. 1, 2, yeah, 1 lakh. So how many bolts are good bolts? Around 60,000. So probability is what? 60,000 divided by total number of bolts. How much is that? 0.6. Can I take P as a 0.6, guys? Okay, perfect. So this what I calculate. This can be your P or P naught. I can be because this sample. I'm kind of this is a P. You guys understood this now? Now, tomorrow I'm going to produce 10 bolts. Now, the question is like this. Let's say Srikanth is a manufacturer of the bolts. I'm from, let's say, some ISRO. We want to use the bolts which produced by Mr. Srikanth. Clear? Now I have I have to have 3 bolts. How many bolts? 3 bolts. My requirement is how many bolts? 3 bolts. Now I go to Srikanth and I ask Srikanth, I need 3 bolts because to complete the mission. But to meet my requirement, how many bolts he has to produce? Let's say he is able to produce, let's say, 10 bolts per the particular day. Okay, 10 bolts he is able to produce. But 10 bolts need not be all the good bolts. His machine can manufacture 10 bolts. All are with me what I'm saying? His machine can manufacture how many? 10 bolts. If you produce 8 bolts, I am 95% sure that I am going to get at least 3 good bolts. You guys are understanding? You guys are understanding? What about this? Anyway, if I am increasing this, anyway, things are going to increase further. Yeah, 97%. All with me? All with me? So, how many bolts he has to produce so that I'll get at least 3 bolts? Why 10? Only 9. 97%. Okay, let me answer this question like this. If you want to make 100%, what is going to happen? His N is increasing. When he is producing more number of bolts than what I require, it is going to be wasted. He has to produce minimum number of bolts such that he meets my criteria as well. He is economically good. It should fetch both the cases, right? Or you ask, otherwise you ask me to produce 100 bolts, anyway I will get 3 bolts. Is that is going to work? You guys are understanding? I need only 3 apples. If you ask that person, shopkeeper, to keep 100 good apples on the floor, is going to do that? Makes sense or not? So what you need to think always like this. With the minimum things, I need to satisfy the client. So now the question is, how many minimum number of apples he has to keep on the floor such that this customer will get at least 3 good apples? That's what I need to keep. You guys are understanding? If I keep more number of apples, anyway you get at least 3. But it is maybe, I'm in trouble now as a shopkeeper. Why? People don't buy, and I exposed to some bacteria attack, apples spoiled. Possible? Which I don't want. So how many minimum number of apples I need to keep on the floor? At least I'll get 3 good apples. That's what my interest. You guys are understanding this? Interesting or not, guys? Is it interesting? Is it interesting, guys, online? See the power of Bernoulli. I mean the binomial. So instead of this, no. I don't want to do this. This is what? 0.6. 0.6 is the capability of the machine. If I have a very good reliability machine, I can produce more number of good bolts. 0.6 is what? The capability of machine, right? Is it not the capability of the machine? So if I have a very good machine, accurate machine, this will go up this speed. Now I want to buy a new machine. Still I want to produce 5 bolts. I don't want to increase my number of bolts. Why? Each bolt, let's say each bolt is costing me, let's say 1 lakh rupees. If I produce 9 bolts, 9 lakhs. I don't want. But this customer is demanding only the 3 bolts. What about the rest of the bolts? No one is going to use on the earth, let's say. I'm in loss. Makes sense or not? Which I don't want. So better I buy a new machine which is a high capability. What is the capability of the machine I need to buy? Now the capability of the machine is how much? 0.6, 60%? What is that capability I need to buy? So that this will become the probability of giving at least 3 bolts is going to go high. Makes sense? Makes sense, guys? Very powerful, huh? Very powerful, the technique. Let us see. 7 maybe. Let's say every increase in the good capability, I need to invest a lot of money. I need to have a optimal reliability of the machine such that I'll get at least 3 bolts. Because every time he is demanding only 3 bolts, let's say. Makes sense or not? How much is this? Still it is a 83%. Yes or no? And what about this? Maybe 7, 5. 90%. So this is a trial and error method I can solve like this. So now what is the meaning of this? Srikanth is 90% confidence that using this capability machine, he can give at least 3 bolts to me. Mandi. Things are clear? Okay. Now instead of, I don't want to do this trial and error business. Let me use a software to solve this. Okay. I'm cutting it. Now, let's say this is a 0.6. Still I'm looking at this. What is the capability of the machine? Tell me what confidence he should have, so that based on his confidence only, he has to buy that particular capability of the machine. I'm 95% confident that I should get at least 3 boards. So what is that reliability of the machine I should have? That's what is the problem in the real one. So what is this? 3. How much you want this? That's a 0.9. Is that is okay? The question is this. I want my confidence should be 0.9 to get at least 3 volts, such that what kind of capability of the machine I need to buy. Things are clear? Let me repeat one more time. I need to get at least 3 volts with 90% confidence that what kind of capability of the machine I need to buy. If this is clear, what to do? So you can solve this using this one. There is something like what if error. Go to data. Please make a note of all these steps. What if analysis. This one. See, Excel is so powerful. I don't need any software. Goal seek. Made a note of it. Goal seek. You see this data box. Now what? Set the cell to what value? This is the cell I want to set to what value? 0.9. By changing what? Capability of the machine? By changing the cell. What? By changing the capability of machine? Go here, keep this, say okay. You got the answer? What is that? This became around 0.9. And what is the capability of the machine I need to buy? 0.7532. You guys understood this? Let me repeat one more time. We solve more number of problems like this so that you guys understand how this binomial random variable is so powerful. Immediately you can go to your office and implement. Immediately. Please do that so that you'll get a lot of understanding of the subject. Let me do it one more time. I will explain the scenarios where you are going to implement in your organization. Okay, that also we'll see. Well, let me complete this one. Sorry. What if, right? Goal seek. Where this is available? Maybe based on the version of your Excel, you need to find out. Data, this, goal seek. How much I need to keep? Which is the cell I need to set? This one? To what value? Let's say 9.5 this time. I don't know whether Excel sometimes it may not solve. But let us see. By changing what? P value? To get around 95% confidence, what is the machine I need to buy? 0.81. All are with me? Guys? Interesting, guys? No. I don't want to change my machine because it's a very costly. I'll keep it as it is. Now tell me how many more number of boards I need to produce. You guys are clear? Let us solve this problem again, same way. What should I do? What if analysis? Goal seek. This time, also I am keeping this. 90%. By changing what? This one? I hope it is not going to get the negative value. This is Excel problem. It's not my problem. Something wrong. Excel is giving the wrong answer. So if you use sophisticated software like R and Python, it's going to give the proper answer. You guys are getting? But still, I can do this. What it is going to do? Let me explain that also, so that how this problem is getting solved in the software. What I want? Probability of x greater than or equal to 3. How much is this? 0.9. This implies NC3, P is the 0.6, O to the power of 3, 0.5, N minus 3, NC4, 0.6, 4, 0.4, N minus 4, blah, 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 equal to 0.9, right? What is the N value I need to substitute so that I'll get this 0.9? That I'm interested in. You guys understood this? You guys understood this? So solving this kind of equation is very, very cumbersome in mathematics. You guys agree? So what I can do, I put some number here and see it is matching with this or not. Some other number for n, maybe 6, 7, 8, 9, like that. For what number it is matching, that number I will finalize. So this is called numerical search methods. What is this? Numerical. Your entire deep learning going to depend on numerical search method, which we are going to understand in the future. Okay, so what I'm going to do now, I'm going to give a hint because I know the answer already. I'm going to give a hint to the Excel. What the Excel is going to do? It is going to search the value which has given nearby. You guys understood? So I'm giving the 8 here. Now let us see. If I give the 8, because the answer is near to 8. See, 3, 95%, na? You guys are understanding? It's an Excel problem. It's not the mathematics problem. Sorry. By changing this one, everything is perfect or not? Let me keep this. Yeah, this is the 0.9, everything is perfect. It's crying. Around 6. You cannot have a 6.2 boards. Maybe you can produce 7 boards. With what confidence? Still it is wrong. Only 8. So it is not able to find the proper solution near to 0.9. You guys are understanding what I'm saying? I'm not going to find. I'm not able to find. Fine. Let me try one more time. This is a problem with the software. So what I'm going to do is let it make it 7, so that it will search nearby. Sorry, I need to keep this 0.95. I kept because it's not, Excel is not working. I show the same thing in when I'm doing the RR, even in the minute app. Don't worry about it. All are with me. By changing what? This one? How many boards I need to keep? If I want to be at 95% confident, I need to produce how many boards at least? 8. You guys understood now? Online guys, you are able to appreciate how I can solve the problem. So this is a manufacturing problem.